So absolute value equations and inequalities. It starts really, really easy. We'll move into maybe something different that you've seen before. I don't have seen before. I don't know. We'll see. So inequalities are your less than, greater than, less than or equal to, greater than or equal to. The first one just starts out graphing them. So I guess let's go ahead and just write these out real quick. So less than or equal to. I mean, y'all know these, but it doesn't hurt to have it. Greater than or equal to. Turn that math stuff off. Okay, so when you go to graph this, there's a couple tips and tricks, and this does help you when we get to interval notation in a minute. So you have x is greater than or equal to -3. So when the variable's on the left, that when you have the variable and you solve for the variable on the left, that means you can look at the way the arrow is pointing. So the arrow is pointing to the right, so my graph's going to go to the right. There's something else that comes with that. So our rule here for this is when you have less than or greater than, you use an open circle. And when you have less than or equal to or greater than or equal to, you use a closed circle. This signifies that you can equal that point where it's open. It doesn't mean you can equal it. So we'll see this a lot on graphs and different things like that. So this one is greater than or equal to, so we do a closed circle. The arrow's pointing to the right. The greater than, the numbers get bigger as you go to the right. Okay. Like I said, most of y'all can do these pretty fast, but there's something that comes in just a second that I want to make sure we get good. So x is less than 5. So again, you can look at this and the variable's on the left, so the arrow's pointing to the left, so the graph's going to go to the left. It is an open circle this time because it's just less than. So that means you can choose any number less than 5. It just can't be 5 because it doesn't equal 5. All right. Oh, it comes next. The next part comes next. All right, set builder and interval notation. So there are different ways to write this stuff. The one that I like to, well, let me just write the different ways real quick. Okay, so you have interval notation. Interval notation is what we were just looking at. It's like x is, I'm doing it the way I want to do it. -2 is less than x is less than 6. So this means x is between -2 and 6. X can equal -2, but it cannot equal 6, okay? That's called interval notation. And then you have the set builder notation, which is a little weird. This talks about more in like logic classes and things like that, but when we do sets, but you have a bracket and it says x such that, and I'll write what all this out means in just a second, x such that -2 is less than x is less than 6. So I'll write it the same one. So this means the same thing. It's just saying you have a set of numbers. We're naming it x. So the name is x. This little sign means such that. Okay. It's just a different way to write it. It's talking about a set of numbers. A set of numbers where the name of it is x, and x is such that it's defined by whatever's after that right there. The other way to write this is called the interval notation, which is the most common way because, I say it's because mathematicians are lazy, so they want to do things faster. But this basically does a picture of the graph without having to draw the graph. And the way we're going to do this is just like before where I had the open circle and for less than and greater than, and a closed circle for less than or equal to or greater than or equal to. What they use here is they use a parentheses for the open circle for just less than, and they use a bracket for the less than or equal to. Okay. Have y'all seen interval notation at all before? Maybe? Okay, that's good. So on this one, -2, or x is between -2 and 6, I'm going to do a bracket at -2 because it's less than or equal to right here, and then a parentheses at 6. And again, what this is doing is actually just looking at the graph of this and saying, okay, instead of a closed circle, we do a bracket. Instead of an open circle, we do a parentheses, and x is between there. So these all mean the same thing. The interval notation is the most common one to use because it is quicker to write. and it tells us all the information we need. So you use a bracket when it's equal to, and you use a parentheses when it's not equal to. So do a couple more examples of this. If I have, we'll do one more of these. -5 is less than x is less than or equal to 10. This would be, and if you need to draw it on the number line to start, it is not bad to do. X is between -5 and 10. Okay, so that's where I start. X is between -5 and 10. I do a parentheses at -5 and a bracket at 10. Okay. I like to start with these. These are called compound inequalities because they are easier to write with, and then you get to learn what the parentheses and the bracket mean. But this still means x is between -5 and 10. X does not equal -5, and it can't equal 10. When you get into like x is greater than 2, one like this, it is nice if you struggle with this at all to just draw the picture real quick. And this is why I pointed that if the variable solved for on the left, which it is most of the time, the arrow goes to the right, so my graph's going to go to the right. I'm going to do a parentheses because it's just greater than. Okay, so what I write here is I have a parentheses at 2, and then it goes forever to the right. In math, we do forever is infinity, okay? I just do 2 circles next to my infinity because when I try to draw it like this, it gets real sideways real quick. So this still means x is between 2 and infinity. X cannot equal 2. These all mean the same thing, but this is why it's nice to draw the graph real quick if you're struggling with this at all. Arrow points to the right, graph goes to the right, infinity's on the right. Okay, those all correspond with each other. If I have x is less than or equal to 10, on this one, I have a bracket at 10. The arrow's pointing to the left, so my graph's going to go to the left, so I do a bracket. So I have a bracket at 10, and it goes forever to the left, so that's forever towards negative numbers, so I do negative infinity. This is something we will see quite a bit in this class, so it is something we want to make sure we get. You don't always have to draw the graph, but like I said, you can kind of see how drawing the graph helps you draw the picture. X is greater than -5, greater than or equal to -5. So I have a bracket at -5 and is greater than, so it goes forever to the right. And then a bracket at -5 and forever to the right is infinity on the right, okay? We'll probably do a bunch more of these as we go throughout the notes here, but some tips and tricks here to help you. Arrow points to the left or to the right. Should I write that a different way? Arrow points to the right, graph goes to the right. Infinity is on the right. And this works the same thing for left too. That only works if the variable's on the left, but most of the time the variable's on the left. And then the other thing that's nice to know is these are always the smaller number than the bigger number, okay? We read left to right, so you put the smaller number on the left, the bigger number on the right. That always works. And then maybe the last thing, infinity always has a parentheses. Okay. You never do a bracket with infinity because you never equal infinity. So you can't always check these. Like you always put the smaller number on the left, the bigger number on the right. That does help to make sure you get it right. But some of those, that's like I said, just some tips to help make sure you can check your answer real quick there. All right, I'm sure we'll continue to do those, but before we do that, absolute value. The absolute value, if I'm looking at the absolute value of a number, most of y'all know that it turns it positive. The absolute value of -7 is also +7. It always turns it positive. So what happens here is the number inside the absolute value could be positive or negative, and I'd still get the answer 7. So it always turns it positive. The technical definition is, or the mathematical definition is the distance from zero. So like if we're looking at a number line, how far it is from zero. But for our intents and purposes, it always turns it positive. But like I said, you have two different things here that equal the same thing on the right side. So you have to account for the positive and the negative. So on this equation right here, we have to actually solve two equations, because if we get the absolute value of 5, it equals 5, or the absolute value of negative 5 equals 5. So we have to say x minus 3 could be 5, or x minus 3 could be negative 5. Okay, so what you do on these is you always get the absolute value by itself, and then you set it equal to positive and negative, because the absolute value of 5 is 5, and the absolute value of negative 5 is 5. So then I just add 3 to both sides, and I get 8 on that one. Add 3 to this side, and I get negative 2. So either of those would work. Okay, if I plugged in an 8, I do the absolute value of 5, which is 5. If I plugged in the negative 2, the absolute value of negative 5 would be 5. So you can always plug those back in to check. All right, the next one, 2x minus 1 equals 9. Same thing, even though you got a little bit more to work with on the inside. As soon as you get the absolute value by itself, you set it equal to positive 9 and negative 9. So on here, I add 1, which is 10, divide by 2, which is 5. So if I plugged into 5, I do the absolute value of 9, which is 9. Here, I add 1, which is negative 8, divide by 2, which is negative 4. So if I plugged in a negative 4, the absolute value of negative 9 would be positive 9. So anytime you have absolute value, you're going to get two answers. I guess unless it's equal to 0. All right, the next one. So I've said this a couple times. Wait, before I go to that, I do want to do something real quick here. Just an odd one out. So if I have this one right here and I rewrote it as equals negative 10, the absolute value can never equal a negative number, right? Because it always turns it positive. So this one is no solution. If you ever have it down to where you only have the absolute value by itself and it equals a negative number, it is no solution. Absolute value never equal a negative number. All right, so now when I go to this one, don't assume just because it's negative right here, we can't do it, because I've said it a bunch, but we haven't done a problem yet. You got to get the absolute value by itself first, okay? So what we can do here is divide by negative 4, divide both sides by negative 4. Now I have the absolute value of x minus 5 equals positive 6. So you can get rid of that negative 4. You want to get rid of anything that's bugging the absolute value to get the absolute value by itself, and then you turn it into the two equations. So x minus 5 equals positive 6, x minus 5 equals negative 6. So I add 5 is 11, add 5 is negative 1. So get the absolute value by itself and then split it into two equations. All right, back to inequalities. A number is at least 12 into a one-step inequality. So a number we'll just say is n. They'll usually tell you what variable to use, but a number n is at least 12. So when you start doing these, sometimes it is hard to think about what at least at most is. At least you use greater than or equal to. At most, you would use less than or equal to. So it's going to be at least 12, so it could equal 12, but it could be something more. but at least in most can sometimes throw some people off. Oh, and our next one is at most. So a number is at most 7. That means the biggest number it can be is 7, but it could be anything less than 7. All right. Writing in a real-world situation, a car rental company charges $30 per day. So that's a base fee, plus an additional 20 cents per mile. So we do not know how many miles we're driving. So write an inequality to represent a situation where the total cost must be less than $50. We don't know how many miles we're driving, so we're going to multiply this. If it's 1 mile, it's 20 cents. It's 2 miles, it's 40 cents. 3 miles, it's 60 cents. And this has to be less than $50. And it's just going to be less than because it just says less than. It doesn't say less than or equal to. This is kind of back to something easy, I feel like. Writing an inequality given a graph on the number line. So this would be what? X is greater than 6. Right? It's just greater than because it's an open circle. It's greater than because it's going to the right. It's going to bigger numbers. All right, solving inequalities. You solve them just like an equal sign. There is one catch to these. We'll talk about that in just a second. Does anybody remember the one thing that you got to do different? Yes.
Actually, I forgot.
What do you say? Actually, no?
Yeah, I forgot.
You forgot. Okay, we'll do it in just a second. All right, so solve it just like it's an equal sign. Subtract 4 from both sides. So 3x is greater than 6. Divide by 3. So x is greater than 2. I don't know for sure if this topic requires you to write it. Write it in interval notation, but we probably should get in the habit of this. If you need to draw the picture, do it. X is greater than 2 would be a parentheses at 2, and it goes forever to the right. Arrow points to the right, infinity's on the right. So you solve these just like it's an equal sign. There's not really any difference. You may have to write it in interval notation. There is one difference, and maybe we'll see it on this problem. All right, so on this one, you want to get your x's together on both sides. So I subtract 5x from both sides, and I get negative 7x plus 8 is less than negative 6. So now to get the x by itself, I need to subtract 8 from both sides. So I get negative 7x is negative 14, less than negative 14. Anybody remember the one catch now? Yes. If you divide or technically multiply by a negative, you have to flip the sign. Okay. If you divide or multiply by a negative, you have to flip the sign. So when we go to solve this one, we are dividing by negative 7. So we are going to flip the sign the other way. And it's x is greater than 2 is my answer. Which I guess we just did that in interval notation. Parentheses 2 to infinity. So you solve it just like it's an equal sign. But if you ever divide by a negative, you flip the sign. Sorry, I'm going back up here for just a second because I just common mistake. And I don't need a hard problem to show that. Let's change this to So on this one, you add 5 to both sides and you get -4. On this one, just a common mistake, I'm going to divide by 2. So I get x. I do not flip the sign. I'm dividing a negative number, but I'm dividing by +2. So it's only if you divide by that number, okay? If you divide by a negative number, don't get confused and think if you divide a negative number. It's if you divide by a negative number, then you flip the sign. Here we got a different one of these. X is less than or equal to -2. So infinity's on the left. When infinity's on the left, we make it negative. And the -2 with a bracket because it is less than or equal to. So it's only when you divide by a negative number. Like when I go to this step right here and I say I divide by 2, I do not flip it. If I say divide by -5, I'm going to flip it. All right. This says solve the compound inequality. Well, it's already solved. And graph the solution on... Let's put a... Sorry, I know you're writing stuff, but let's put a +2 in there. Just to have something to work with here instead of just graphing it. All right, so on this one, if this wasn't here, like if we didn't have this right here, it'd be just like the problems we were just doing and we just subtract 2 from both sides, right? So what we're going to do actually here is we're going to subtract 2 from both sides. We're going to subtract 2 from every side. You subtract it from the left, the middle, and the right. So this becomes -4 is less than x is less than 3. So you do it just like an equation, but instead of just doing it on the left side and the right side, you got to do it on the left, the middle, and the right. So now to graph this, we would do a closed circle and then an open circle, and x is somewhere between there. So this would be a bracket at -4 and a parentheses at 3. All right, another one of those, -3 is less than 2x plus 1 is less than or equal to 7. So again, if you need to just like cover it up with your hand and pretend this isn't there for a second, you would just subtract 1 on both sides. All right, so I'd subtract 1, but I got to do it on all 3 sides. So this becomes -4 is less than 2x is less than or equal to 6. And now I'm going to divide all 3 sides by 2. So -2 is less than x is less than or equal to 3. So I have a parentheses at -2 and a bracket at 3. Parentheses at -2 and a bracket at 3. X is somewhere between those. All right. Word problem to end it. A phone plan charges 0 or 10 cents per minute. So we kind of talked about that a second ago. 10 cents per minute. That's usually you take it times X because we don't know how many minutes we're spending. Plus a $15 monthly fee. Write and solve an inequality to find how many minutes you can use if your bill must be less than $25. Okay. So now we are actually going to solve this. I'm going to subtract 15 from both sides, and I get 0.10 is less than 10. Oh, I forgot my x. And then divide by 10 cents. That would be 100, right? Math is hard at 8 a.m. So x is less than 100. So as long as you spend less than 100 minutes, your bill will be less than $25. To write this in interval notation, negative infinity to 10, and a parentheses on both sides. Yes.
Can you do a problem about how to write compound inequalities into interval notation?
The compound inequalities interval notation?
Yeah.
Do you have one right there or something
Yeah.
on your screen?
Yeah.
Okay, I'll do it in just a second. The last one, I guess we'll do it real quick because it is at most $2.50 each. So each drink, that's where you do the X, because if I buy 2 drinks, it'd be $5 plus a $5 service fee, and it must be at most $20. So it must be less than or equal to $20. That's where the at most and at least get hard. So you got to pay attention to those. So on this one, we subtract 5 and then divide by 2.5. What is that? 6. Oh, I forgot I put equal instead of. So X is less than or equal to 6. So I do a bracket at 6 and it goes forever to the left. So as long as I guess in this scenario, I'm sorry, interval notation doesn't really make sense on these problems because you can't have negative minutes or negative coffee drinks. But I was just writing them to let you like practice interval notation. Does that make sense? Like this really can't be less than 0. I feel like I should erase those, but at least we practiced them. You always try to. Okay. It's coming back up. So one of these topics, I was wondering when I said that was super easy, I was wondering why I did it like that. So this topic, this solving a compound linear inequality interval notation, this one is probably the toughest one. So what you do, we'll talk about the or and the and in just a second. Let's just work the problem out and get our answer. And I'll show you what to do. So 2y plus 1, we are going to subtract 1 from both sides and then divide by 2. And then on this one, we are going to subtract 4 from both sides, which would be -3, divide by 3, which would be -1. Okay, so the rule for or and, you can go ahead and mention, in math, they use like this symbol for or. It's called the union symbol. And what it means is like when you're talking about sets, yes.
Are you using the equal, like greater than or less than or equal to, or just the less?
Oh, I'm sorry. There. That what you mean? Yeah. So the union right there or the or, it means what I think about is it union means like marriage. It means like bring together. So it's like everything. It means you bring it together. The symbol they use for intersection or and is this one. Intersection, and it's what they share. Okay. The intersection is the word and. We probably won't use those symbols that much, but it's just something that goes along with those words. All right. So what you need to do on these to make them easier is I would graph them, okay? And it is nice because I got the different colors. But if you graph these, I have y is greater than or equal to 6. So that is going to be a bracket and is greater than, so it goes forever to the right. Okay? Y is less than -1 is going to be a parentheses, and it's less than, so it goes forever to the left. Okay? All right, so now we have to focus on the word or. So what this is saying is my answer could be the red or the blue line. It's bringing them both together. Either answer will work. Basically, it's saying if I do the blue line, this one works, it's good, even if this one doesn't work. Or it's this one could work and this one doesn't work. It doesn't matter as long as one or the other work, okay? So the way I'm going to write my answer is in interval notation. I do from -1 to -infinity for my red line. And then for my blue line would be 6 to infinity. And I put the union symbol in the middle to say that it could be the red line or the blue line. It could be my red line, which is this one, or it could be my blue line, which is this one, okay? That is my answer for this because it could be either one. So it's always nice to draw the picture out and then look back and say it's or, so it could be the red one or the blue one. And you put it together like that, okay? When you go to do the other one, here I divide by -4. Well, I'm dividing by negative, so I flip the sign. Smack her.
I'm sorry.
So now on the I get my answer for that one. On my left, on my one on the right, I subtract 1 and I get -4. I divide by 2. I get -2. Okay? Again, I'm not even paying attention to the and or the or right now. I'm going to go graph it. Did I write one of those wrong? Greater than or equal to. No, I'm just going to have to do another one. Okay. So on my blue line, it is less than. So parentheses to the left. And a greater than or equal to is to the right, so it goes forever to the right. All right. Now, this is why I was saying I was going to have to do another one, but we can shortcut that one. Now I go back and I look at the and. The and is the intersection. So I want any spot where the red and the blue line are intersecting. Well, the red and the blue line do not intersect. So my answer for this is actually the empty set. There is no answer. It's like no solution. Okay. I think it said to write the empty set on that. Yeah. If there is no solution, do the interset. Okay. So these have no intersection. Okay. If you got down and your answer was like this, -2 and 5. Oh, let me change my colors here because I like my red line and my blue line. So my blue line, we'll make that less than or equal to just because. Okay, so my blue line is greater than -2, so it goes forever to the left. On my red line, it's less than or equal to 5, so it's a bracket, and it goes less than. So this again is and, so I want to know where the red and the blue line are intersecting. So my answer for this one is -2 to 5, because that's the area where both my red and my blue line are. The red and the blue line. Okay. So this is the difference between the and the or. The or, you bring them together, so either answer will work. Either line, the red or the blue line will work. The and, you only want what they share, which is the intersection, where the red and the blue line are. So it's always good on these to draw out a picture and just be able to look at the picture and tell. So solve it, draw the picture, and then go back and say, okay, if it's or, I want both lines. So I write both of them. If it's and, I just want the intersection part.